Okay, so I think what I'm going to do next is some problems that are probably a little bit more advanced. Okay, we did quite a few of these last time. So this would be, all these problems on this you have to use a chain rule on because you have a composition of functions. You can kind of think of this example 1, it's just the square root of something. Right, so in general, if you're going to do like, if you were going to do the derivative of this, which we're going to do, you would kind of think of it as f of x to the 1/2 power, okay? And when you do the chain rule, you don't have to write this down, you just pay attention to what I'm explaining, is if you do the derivative of this, what are you going to do? You're going to do 1/2, you're going to leave the function alone, you're going to subtract 1 from the exponent, but the chain rule says you multiply by the derivative of that thing that's under the radical. Okay, that's the extra thing that we were working on last time. All right, so let's go ahead and start this off then. So we're going to start this just by writing this as y equals, and I'm going to put like a bracket on here. So I've got 3x minus 2 to the second plus 2x and the whole thing to the 1/2 power, like that, okay? Now we're just going to use the chain rule. I mean, it would be okay to multiply that out and FOIL it and collect like terms. If you wanted to do that, that's fine. I'm just going to leave it alone because now that we know the chain rule. And this is probably an example of a problem where you're going to do a chain rule within a chain rule. Okay, so we're going to start by doing this like this. So we just say dy over dx. Go ahead and do your derivative. So what do we do? It's power rule, really. So you're just bringing down the 1/2. You're leaving what's inside this bracket alone. Don't touch it until you differentiate it with the chain rule. So that's going to be 1/2 minus 2/2. You can do that in your head if you want to. I don't mind if you do that in your head. And then we're going to multiply that by the derivative, by the chain rule of 3x minus 2 to the second plus 2x, like that. Okay? All right, so now we're going to do this. Okay, so we're going to focus on just that derivative right there, and then we'll simplify maybe a little bit on these. You know, I'm not going to simplify maybe totally on this, but somewhat. Okay. All right, so the next step, I'm going to bring this down. So that's going to be 1/2 3x minus 2 to the second plus 2x. Okay, that's going to be negative 1/2 power. Okay, we just leave that alone. We could, at the end of the problem, make that into a negative exponent if we wanted to. Okay, now let's focus on this. Now, there's two choices you have. You could multiply that out, collect like terms, and do it that way. Okay, or you can just do it like this. What I'm going to do is I'm going to do a chain rule here. Okay, so I'm going to be working on this derivative here. So that's a power rule. So you're going to bring the 2 down. You're going to leave the 3x minus 2 alone to the first power. Then what are you going to do? You're going to do the derivative of what's inside, which is what? In your head? 3, good. So you can just write that like that. Okay, that's the thing that students a lot of times forget to do on this problem, is that's another chain rule within a chain rule. See, so you're bringing the 2 down, leaving that alone, subtract the exponent times derivative of what's inside. You guys understand that okay? Okay. Now what's the derivative of 2x? Plus 2. Okay, there's your derivatives. Okay, the calculus part's done, and all we're going to do is a little bit of algebraic simplification on this. So we'll just go ahead and do this. Let's go ahead and make the exponent positive. Okay, so we have a 1/2, and we're just going to take this whole entire thing right here, this whole thing right here, and just bring it to the bottom like that, so we have a positive exponent. Whether you turn it back into a radical is up to you. It doesn't really matter. So I'm just going to write this as 3x minus 2 to the second plus 2x to the 1/2 power. I think I might have an extra parenthesis in there that I didn't mean to have. Okay, so we can do that. That's so cool. I can erase stuff. I don't get Windex like on the board. I never run out of ink. This is just so cool. All right, now the next thing we're going to do is just kind of clean this up. Okay, so if we do this, I'm just going to write this kind of at the side right here. This is really going to be 6x minus 4, And then, or actually, you know, it'd be better if we just do it like this. This is 2 times 3.
Shouldn't
So
there
that's,
be an x next to the 2, or am I wrong?
what's that?
The 2 plus 2, should there be an x next to it? Or
Oh, this right here where the 3 is?
Yeah.
No, that's because what I did was I did the chain rule. I did the derivative of what's inside. So the derivative of what's inside is 3. It's the number in front of x, okay? All right, now I've got 3 times 2 is 6. Like this. I'm just sort of doing this at the side of the paper so I can just get the final answer written here. Okay, like this. So I'm just going to work this out. Okay, so that's going to end up being 18x minus 12 plus 2. So that's going to be 18x minus 10. So that's the result of this. So what I just did is I just algebraically simplified that kind of at the side of the paper, and then I'm going to put it here.
How did you get the 6 outside the parentheses for?
Okay, look at this. 3 times 2. Look at the 3 times 2.
Oh, gotcha.
Okay, you get into some pretty messy expressions, so I didn't give myself enough room, so I'm kind of writing this in a kind of a sloppy way here. So anyway, this whole thing right here would be 18x minus 14. Now, there are other things you could do to that problem. Okay, it's okay to stop there. Minus 10. Not 14, 10. I'm sorry, I know that. Negative 12 plus 2 is 10, right? Okay. All right, so we just need to change that to 10, and then that's a good enough answer for what we have here then, okay? All right, let me kind of go back through a couple of things on that, what I did. And again, this is chain rule. So the first thing you guys want to make sure that you understand is what I've done here. So again, I brought the exponent down, so I got 1/2. This stays the same, negative 1/2 power, then derivative of what's inside. I see hands going up. That either means I made a mistake or something else. Well, so what do you say?
I think 18x minus 10 should be on the top of the fraction, isn't it?
Well, I tried to write it at the side, but you're right. It would be better if I wrote it that way. I was trying to write it at the side, so let's write this better. Like this. Let's write this.
Doesn't the 2 also cancel out?
You could if you factored a 2 out of that, which is what I'm going to do. So I'm going to put that in the top. I just didn't write this very well because I'm kind of running out of room here. So I got 2 times 3x minus 2 to the second plus 2x, like that. Okay? Does that look okay to everybody so far?
So why does the 18x minus 10 go to the top?
Okay, well, because we're multiplying by the derivative of this, so technically it's over 1. So you're just multiplying by that. That doesn't go to the bottom with the 2 because it doesn't have a negative exponent. The reason I brought this thing down to the bottom was because of that negative exponent. So that's not down there with it. Now, yeah, go ahead.
Never mind. You just answered my question.
Oh, okay, good. All right, now. Somebody said, can the 2's go away? Yeah, you can factor a 2 out of the top. So we're going to go ahead and just do that. Take a 2 out of the top, and that's going to be 9x minus 5. All over 2 times 3x minus 2 to the second plus 2x. Then it will cancel out. So probably the best final answer would be 9x minus 5 over... And I think I lost my 1/2 power. Okay, so that 1/2 power needs to be there. So it's 9x minus 5 over 3x minus 2 to the second plus 2x to the 1/2. Okay, so that looks like a good answer. Now, when you do some of these problems that get a little bit more complicated, it's pretty easy to make a little mistake or two on them. I didn't do a very good job of leaving myself room on the handout, so that's kind of what causes some of that too, is you give yourself plenty of room. Okay, so is any other questions you got? Yeah.
Didn't the second power in the denominator go away when you did the derivative, when you pulled it up front?
Which part are you looking at here?
So if you go to the part where there's 2 different kinds of highlighting in the same one.
Oh, right here?
You moved the 2 to the front, so it's no longer to the second power, correct?
This...
And then on the very next chart, you have the second.
Oh, okay. Well, see, okay, this part right here stayed the same, okay? This part right here is the same, right?
The part that goes to the top.
Right, and I know what you're looking at. When you get these problems like this, you start looking at the wrong parts of it. So the reason it went away is because when I did the derivative of the inside part, that's how that happened, okay? All right, that's a pretty good problem. These are a little bit more complicated. Any other questions about that? Okay. You're doing a chain rule within a chain rule. Now, you're probably never going to do a chain rule within a chain rule within a chain rule within a chain rule within a chain rule like I was doing with the Russian dolls. But theoretically, you could do that, okay? Generally, about 3 is about as much as you're ever going to do. Okay, so this, again, is a chain rule problem. Now, what you have to look at on this problem is, and you don't need to write this down, I just want to sort of talk through the general idea of what's happening on this problem. Really what you have is the sign of a function, okay? And that function that's composed within a function, embedded, is that thing right there, okay? So, what is the derivative of a sine? It's cosine. So if we did the derivative of this, just in general, and you don't need to write this down necessarily, you would just do that would be the cosine of f of x. Then the chain rule would tell you to do what? Multiply by the derivative of what's inside. So in general, that's how you're going to start the problem out. It's the sine of something, okay? So when we put this together and do dy over dx, okay, remember, we're just looking at this as the sine of something. The derivative of the sine of something is the cosine of something. And then that part that's highlighted is going to stay the same. Okay, I'll try to highlight, stuff as I do this and see if that kind of helps you guys reason through what I'm doing. Okay, what do I do next? According to chain rule, I multiply by the derivative of what's inside. Okay, what I highlighted in that problem. So we have the cosine of e to the x like that. So that's the beginning of the derivative. It's not the end of the derivative, but that's the chain rule. So does that make sense? Okay. Now what we're going to do is we're going to bring this first part down because that's done. We have the cosine of e to the x. You can do a cosine of a cosine. Okay, like that. Now this part right here that I'm going to work on next is going to be another chain rule. Okay, so think about if I just wanted you to do the derivative of the cosine of x, what's that? Negative sine x. However, this is the cosine of a function, so you have to apply the chain rule when you do this then, okay? So I'll do this in a different color, okay? So let's do that. The derivative of a cosine is negative sine of itself, right? Then what? Times the derivative of what's inside. That's a chain rule again, see? So you're using a chain rule within a chain rule again. Does that make sense? Okay? Anytime it's the cosine of something other than x, then there's a chain rule going on in there. Now we're ready to clean this thing up. We got one more derivative to do, then we'll just clean up whatever we can do. Well, there's my favorite derivative. So what's the derivative of e to the x? I love that one, right? Okay? All right, I've got that one down, and you do too, right? All right, so we got cosine of the cosine of e to the x. That's done. There isn't anything else you can do with that. You have a negative here, so it's logical to just put that negative in front there because you have a positive times a negative. And then here you can write a bracket or you can leave a bracket off. We can just say sine of e to the x, and then this derivative, of course, is e to the x. Now, that's really a derivative, and it's really simplified. It's just probably best to write this like this.
Is it still negative sine e to the x or is it positive sine e to the x?
So it turns out negative cosine because you're looking for the derivative of it.
Okay.
Okay, you good? I didn't get the question, but it looks like you got answered. Okay, all right. Okay, everything else good?
Yeah.
Okay. Now, you could write the answer that way. I think it's probably best to put that e to the x in front. The only reason I suggest that is if you write it like this, there's a tendency, if you're not paying attention, to think that e to the x, this one right here, belongs to that sign, and it doesn't. So it's just kind of outside of it. So I'd probably write the answer like this. Write the cosine of e to the x, okay, like that, and then times the sine of e to the x like that. That'd probably be the best way to write your answer, okay, like that, okay? So it's these things are sort of just exercises to help you understand the chain rule. That's what it's all about. And a lot of times in math we do exercises, just like musicians do exercises, to kind of help you with concepts and techniques. Okay?
So you change the e to the x to negative because it's all one term.
No, it wasn't negative. The negative right here, if you're talking about this, that came from the derivative of the cosine.
Right.
Remember, the derivative of the cosine's negative sign. That's where it came. Okay, the derivative of e to the x is itself. So that just came down like that.
Well,
Okay?
I'm saying when you moved negative e to the x to the very front, at the very last part.
Yeah.
So you moved that to the front because, I mean, it's all, that entire term is all being multiplied by each other. So when you bring that to
It's
the
the
front,
reason I did that is because for lack of confusion, okay, like this part right here, that e to the x is not a part of the sine function.
Correct.
Okay, it's outside of it. So if you wrote it this way, you might think that you're doing the sine of e to the x times e to the x. That's not true. You're just doing the sine of e to the x only. That's why I wrote it in front, because it looks better. It's less ambiguous. That's the idea. Okay? Okay. All right. So let's look at one of these. These are also chain rule problems, and then that's probably about as complex as I want to take this. Okay. So what would you do first on example 3 probably? You probably want to go ahead and write all of your radicals as 1/2 powers, like that. So we want to go ahead and do that. Okay, now we're ready to do a derivative. Now this is a chain rule. Now what this is doing, and you don't need to write this down necessarily, it's just I'm trying to get you to think through this stuff correctly. The structure of this problem is you have something to a power, right? So it is a power rule kind of a problem. So when you're doing this, what are you going to do? You're going to do 1/2, you're going to leave the function alone, you're going to subtract 1 from the exponent, okay, and then what do? You multiply by the derivative of what's inside. Okay, that's chain rule. So that's exactly the approach we're going to take on this problem. Okay, so let's do that. So you're going to bring the 1/2 down. So that's going to be 1/2 times t plus t to the 1/2. And then that's going to be to the 1/2 minus 1. You can do that in your head if you want to. I usually just like to write that on there. Now I'm going to do the derivative of what? What's inside, exactly. Okay, inside the, that's what I was trying to do with that Russian doll. Okay, all right, so that we're going to just write down that we're going to do the derivative of t plus t to the 1/2 like that. So I'm doing the derivative of what's inside. So the thing on this is, remember, you leave that alone. That's not going to change. Now we're going to do this derivative like that. Okay, all right, so we're going to have 1/2 of t plus t to the 1/2 to the negative 1/2, and we could probably change that to a positive exponent at the end of the problem. Now let's focus just totally on this derivative right here. Okay, and that's just basic power rule stuff, right? So that should be a pretty easy thing to finish up then. So the derivative of t is what? 1. And then this is power rule here, so that's what? 1/2 t to the 1/2 minus 1. So that would be 1/2 t to the negative 1/2 like that. Now that is your derivative right there. What did I just do? Okay, so we got that. All right, does that look okay? Okay, that one's a little easier, I think, than the last two I've done. Now the only thing I would suggest we do to clean it up is just make a fraction. Let's go ahead and make a fraction with the 2 being in the bottom. And then this whole thing right here that I'm going to highlight here, this whole thing right here goes to the bottom. Okay, now you could put that back in a radical too. I'm going to go ahead and just put that into a radical. You don't necessarily have to, but I'm going to go ahead and just do that. So that's going to be t plus, and you could write that t to the 1/2 back in a radical form again if you wanted to, like that. Okay, so you can do that. Okay, now the numerator, we can just leave it alone. If we want to. Now we do have you could write this probably as 1 plus 1 over t to the 1/2, because you could make that exponent positive. And really for our purposes, that's probably good enough. I mean, what other things could you do? You could probably simplify the complex fraction. You could multiply the top and bottom by 2t to the 1/2. I don't think for our purposes it makes that much difference on this type of a problem right there, so I'm going to stop at that point. I'm not going to take every one of these things down to the end, but there are other things you could do with that, but probably that's good enough. Okay? All right, does that look okay? Okay. All right. So let's do work on this next example here, and I'm not going to simplify this next one very much. I want to just mainly kind of go through the idea on this. So example 4, you're going to write this as it's 1 big 1/2 power. Okay, underneath that, what you're going to find underneath this is this. So I'm going to put that, what I just highlighted, inside these parentheses like that. Okay, this is sort of a nested within in a radical. So that's going to be t plus square root of t plus square root of t like that. Okay, we can do that. Now we can start the problem like that. Okay, then we can move on from there if we want to. Okay, I would probably go ahead and keep rewriting it. And you can do this in your head in one step if you want to. So I'm going to go ahead. The next thing I'm going to do is I'm going to take this thing that I'm highlighting, I'm going to write that to a 1/2 power. Okay, so when I do that, I'm going to have parentheses t plus square root of t. That's all to the 1/2 like that. Okay, does that make sense? It's all how you see stuff. You have to see stuff the right way. Okay, then I would probably go ahead and just maybe change that to a 1/2 power. Then we'll start kind of getting ready with our derivative. So let's write one more step. T plus, parentheses, t plus t to the 1/2, all to the 1/2, all to the 1/2, like that. Okay? You guys see what I'm doing? Okay? You can nest things within infinitely. When you go to Calc 2 and Calc 3, you start looking at these infinite nestings of things and what you look at with series and so forth. So it kind of helps you when you get to that stage. So now what we're going to do is look at finding the derivative. We're not going to do too much simplification on this, though. So when you look at this expression, you got to look at it the right way. Okay, we're just doing that thing right there that I highlighted to a 1/2 power. So what you're going to do is you're going to do just kind of a general power rule. So you're going to bring the 1/2 down. You're going to leave this. I'm going to put this in a bracket. I think it looks better. So I'm going to say t plus t to the 1/2, all to the 1/2. And then if you subtract this exponent, 1/2 minus 2 over 2 is negative 1/2. Then you're going to need to multiply by the derivative of what's inside. Okay? So I'm going to highlight that, and then you just write the same thing there. Okay? It's all kind of the way you visualize this stuff. So I'm going to put in here t plus t to the 1/2 to the 1/2. Guys, that look okay so far?
I just hate it when they use t as a variable.
You don't like t as a variable? Well,
yeah,
t stands for time.
Well, yeah, just like.
Well, plus signs. Yeah, plus signs messes you up, no
I
doubt.
mean, even with the tail, sometimes when you're looking at it, like when you draw your t's with the tail.
Yeah, no, that's the reason I try to make it sort of cursive. But yeah, it's easy to mess up on a t. Reason we do that is what? Physics. Now, physics, t is time, so it's just get used to it. Okay, so now we go on from here. We have 1/2 of t plus t to the 1/2 to the 1/2 to the negative 1/2. Okay, then this derivative right here, let's do this. What's the derivative of t? 1. Okay. Now, how are you going to handle the derivative of the next part? Okay, I try to highlight. That might kind of help you focus on what I'm doing. How are you going to differentiate what I just highlighted? Chain rule again. Good. Okay, so you're going to do a chain rule on that. So you're going to bring the 1/2 down. Okay, like that. So that's going to be t plus t to the 1/2. Subtract 1 from the exponent, so that's going to be negative 1/2. Then you're going to multiply by the derivative of what's inside those parentheses, which is t plus t to the 1/2 like that. Okay, sorry, I'm running out of room there a little bit, but that's how that goes. Okay, so we got one more derivative to do, and then we're done. We aren't going to simplify this one at all. I don't care about that too much. So I'm going to just kind of rewrite things. So this is 1/2 times t plus t plus t to the 1/2, all to the 1/2, to the negative 1/2, times 1 plus, this is left alone, so 1/2 t plus t to the 1/2 to the negative 1/2. Now we need to do this one last derivative and then we'll just quit. That'll be good enough for what we're learning. Okay, so you can do that derivative in your head, I think. So let's do that. So what's the derivative of t? 1. And the derivative of 1/2, what's the derivative of 1/2? Not 1/2. T to the 1/2 is 1/2 t to the negative 1/2. That's good enough. Okay, there's a lot of things you could do on that, but that's good enough. Okay, the point of that problem was to give you an idea of sometimes you have to use a chain rule within a chain rule within a chain rule, and to see if you can follow that logic. Okay, how does that look?
You look a whole bag.
What?
So,
Yeah.
now normally you said that if it started with radicals, you want to put in radicals. So, like,
It's the complexity level of this.
my math lab will probably ask for it in radicals, right?
I sort of doubt it on this problem. I really doubt it because of the complexity level of it. If you've got it in this form, you're probably good. Because the algebra could really get messy on this one. I mean, you could really have a lot of work to do with the algebra. To me, that's fine. You've done all the derivatives. Everything's fairly clean, so that should be fine on that. Okay? I think the same thing. These type of problems that we just did today are all kind of like that. Okay? All right. Any questions about that? Okay. Now we're going to do one more round of these things, and what we'll be looking at is just sort of some combined rules to finish up. I'll give you time to not do the ones I just did, but one's kind of like this. So this is kind of when you get into combining your rules on this one. So you have to kind of think about how you start on this. The thing that students a lot of times don't do correct on this is look at it the right way. When I'm looking at this problem, here's how I'm looking at it. I'm seeing a function to the 5th power, right? Function to the 5th power. So how do you differentiate something to the 5th power? What do? You bring that down, you leave the function alone, subtract 1 from the exponent, then you multiply by the function. Okay? That's exactly how you're going to do that problem. You have to look at it the right way. Now, you see a quotient in there too, right? A quotient rule is going to be a part of this derivative, but you don't start that way. You start with this rule because the whole thing's to the 5th power. Okay? So when we get this set up, let's start it this way. Okay, we're going to bring down the 5. Then you're going to leave what's inside the parentheses alone. You're not ready to do anything with that yet. Subtract 1 from the exponent. Then what does the chain rule tell you to do? Multiply by the derivative of what's inside. Okay? All right. So now, let's focus on the derivative. What do you do to do that derivative? That's a quotient rule, isn't it? Okay, good. So we got to do a quotient rule. And the quotient rule, I'll just write it up for it's bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, so we got to do that. All right, so we're going to leave this like this, bring down the 5, just leave this alone. Okay, now I'm going to draw a bracket, so we're going to do the quotient rule on that then. Okay, so when I do this, you're going to take the bottom, which is x plus 1. Now let's do some of this in our head. This is not a hard one to do. So the bottom, what's the derivative of the top? That's 2. So you just go ahead and write that. Minus the top, which is 2x. And then what's the derivative of the bottom, x plus 1? That's 1. Okay, so you can do little things in your head like that to save you a step. And then you do the bottom squared right there. So that really is the calculus. The calculus is done. Okay, we've done the chain rule, we've done the quotient rule. Rest of it is let's see what we can simplify. Okay, does that look okay so far? Okay, all right, so now let's see what we can do with this. We have 5 times 2x to the 4th, or 2x over x plus 1 to the 4th. Let's clean up what we did on the quotient rule. So you've got a distributive property there, so that's going to be 2x plus 2. Minus 2x, that's kind of nice, you're going to have a cancellation, all over x plus 1 to the second. So we have that. Those are going to cancel. Now there is a little bit of algebraic simplification that I'd like you to do on this problem. So notice on here when you do this, you just have a 2, right? And you have a 5. And it's all multiplication. See, right now what you have is 5 times 2x to the 4th times 2. That's what you have left. So how are you going to write that? 10 times 2x to the 4th. Okay, you don't have to multiply out the 2x to the 4th, although you could. Okay, we'll certainly look at that. Okay, then the bottom on this, if you look at this part right here, really what you have is you have x plus 1 to the 4th, like that, and then over here you have an x plus 1 to the 2nd. Okay, you guys see where I'm getting that x plus 1 to the 4th? Well, it is to the 4th, right? This whole thing right here is in parentheses, so it's to the 4th power. Now, there's probably one other thing that I'd probably like you to do on this problem. What can you do with the denominator? You can simplify that. What is it? It's x plus 1 to the 6th, right? Because you add exponents. So in general, if you have something like this, if you had x to the 4th times x to the 2nd, that's x to the 6th. Okay, so you can add those exponents. So probably the best final answer on this would be like this. Now you can multiply this out. I think I'm going to go ahead and do this. So 2 to the 4th is 16. Then you would have x to the 4th. Then you could put this all over x plus 1 to the 6th. So probably the final answer, best answer would be 160 x to the 4th over x plus 1 to the 6th. Okay, so the algebra really comes from these things. You have an x plus 1 to the 4th here, x plus 1 to the 2nd there, add the exponents. So look at the algebra and tell me if there's anything you need me to clarify. It's always the algebra on this more than it is calculus. Okay? Good? Okay. All right, that's kind of a good problem. That's got a little algebra exercise in it too that's kind of good to look at. Okay, let's look at this one. Okay, theta. You can have theta as a variable. So with this one, we would write this in Leibniz notation as, you got a question? Is there something you want me to look at?
Yeah, the 16. Yeah, where'd you get 16?
Or from here, 2 to the 4th.
2 to the 4th.
I went ahead and did 2 to the 4th. Okay, because see what this part is saying. This is really saying 2x times 2x times 2x times 2x, right?
Yeah.
So that's where the 16 comes from. Okay, and then the way I got a 6th power on the bottom was this is an x plus 1 to the 2nd. Over here, this is x plus 1 to the 4th.
Okay.
So you add the exponents. Okay, like that. Okay, all right? Okay, so this one right here, you're going to do a what kind of rule? Product rule. Okay, there are two functions being multiplied. Now there's going to be a chain rule involved in this also. So what we're going to do is the product rule goes first times derivative of second plus second times derivative of first. So we're going to do that. Right? So we write down the first, which is theta. We multiply by the derivative of the second, and let's just write it this way before we crunch it out. Okay, plus secant of 4 theta, and then times the derivative of the first, theta, like that. So that's your product rule. Again, we did the first times derivative of second plus second times derivative of first, like that then. Okay, so that's kind of the idea on that then. And let's see, the derivative of the secant is the, I hope I'm right, secant tangent. I gave you guys a formula sheet last time. There's two or three of them that a lot of times I forget, so that's one of the reasons I showed you how to derive them. But from a student perspective, you want to have those down pretty good so you don't have to waste your time deriving those. Okay, so what we're going to do to finish this up is this is going to be theta comes down. Now this part right here, when we do this derivative here, that is a chain rule. Okay, it's because it's a secant of a function. If it was just the secant of theta, then this would be the answer. Okay, that's one of the derivative rules we learned. So when we do this derivative, we go like this. The derivative of a secant is a secant of the same thing times the tangent of the same thing which is 4 theta again. However, the chain rule says that you got to multiply by the derivative of what's inside. So you have to do that. That's because it's the secant of something other than just theta. Chain rule has to be done. Okay, now if we go to the second part, we're going to have secant of 4 theta. What's the derivative of theta? 1. You're not used to seeing theta as a variable. Like the derivative of x is 1. Derivative of theta is 1, so you have that. Okay? Now, what we need to do on this is going to be theta, secant of 4 theta, tangent of 4 theta, and then what's the derivative of 4 theta? 4. Okay, so you have that. Over here, you're going to have secant of 4 theta times 1, which is just itself. So the best way to write this answer is a couple of things you could do on this. Probably bring the 4 in front, so you would have 4 theta, secant 4 theta, tangent 4 theta, plus secant 4 theta like that. Now you could stop there. I mean, that's a fine derivative and it's simplified. There is one thing you could do. What do you think? There is one thing you could do. You could factor. You're not required to, but you could factor out the secant. You can factor it out. That's a common factor, so let's go ahead and do that. That actually comes in handy for what we do later in this class, so that's what I'm going to do to finish it up. Okay? So let's write this as secant 4 theta as a common factor. Okay? If you kind of blocked that off in your mind, you would have 4 theta, tangent 4 theta, and then this part right here would be plus 1. Okay? And you can write the answer that way too if you want to. So that would be it. Now the part of this problem that might be a little challenging to think about is that chain rule that I did in this. The product rule, not so much, but you got to make sure you understand how I did this. So let's kind of run through that one more time on this. So basically what did I do? I did the secant of the same, tangent of the same, right? Then I did the derivative of what's inside. That's the idea, chain rule, okay? All right, how's that one look? Okay, all right, it's all thought process, all a matter of looking at things a certain way, okay? All right, so let's do this example, then I'm going to give you time to maybe do 2 problems to get this finished up then. Okay, so this one, what do you think how I would start this derivative? This is a product rule problem, right? See, this part right here is the first. This part right here is the second. So we're going to do first times derivative of second plus second times derivative of first. Students have a tendency, a lot of these, to start with the wrong rule. That's an important part as these problems get more complex is look what you have. You have a product, okay? So what we're going to do is we're going to do dy over dx, and we're going to write it, set it up and everything. So what you do is you write down the first, you don't touch it, then you multiply by the derivative of the second. Okay, and we'll do that later. Okay, let's just get it set up. Okay, then you write down the second, x squared plus 2x to the third, and then you're going to multiply by the derivative of the first. So to me, it's important to write that down. You know, instead of trying to do too much in your head, just go ahead and start with that then. Okay, so we're going to do this derivative, and then we're going to do that derivative. Everything else stays the way it is. Okay, does that look okay so far? Okay, that's product rule. All right, so let's proceed to the next step. Bring the x plus 2 down. Now, what kind of rule applies to this derivative right here? That's chain rule, okay? It's something to the third power, right? And if you have something, I can even write this like this. Question mark to the third power, the derivative is 3 question mark to the second power times question mark prime. Okay, right? Okay, that's what you're doing. That's what a chain rule tells you to do. So what we're going to do is bring the 3 down, leave the inside part alone. That's kind of your question mark. That becomes 2. Now take the derivative of what's inside. like that. So you're applying chain rule on that then. Okay, so again, I'll kind of highlight this then, so you can kind of see what I did. That might help you distinguish between the parts of the problem. Okay, does that look okay? Okay, now let's proceed on to the next thing here. Okay, so this comes down. That thing just needs to be written as plus x squared plus 2x to the third. And then what's the derivative of x plus 2?
1.
That's 1, so that's kind of nice. Okay, so that's it. Okay, so you're multiplying that by 1. Okay, now we got one more derivative to do, then we'll look at whatever algebra we can do with this. So I think I'd probably go ahead right now and just write the 3 in front of the x plus 2, leave the x squared plus 2x to the second alone, and now do this derivative, which you can do in your head. So what's that derivative? Right here.
2x plus 2.
2x plus 2, good. Okay, and then this over here, you multiply that by 1, you would have x squared plus 2x to the third power. Okay, so your derivative is officially done. All we want to look on this now is maybe what could we factor. I see a couple of factoring things that we could do on this problem, so I do want to run through that a little bit. Okay, any question about the derivative on that? Product rule, chain rule, kind of embedded within. Okay, now here's a couple of things I spot. You could factor the 2 out of that. Okay, I'm going to start that way and just write that like this. Okay, we're going to write a couple more steps, so let's just keep rewriting stuff. But let's change this part right here to 2 times x plus 1. Okay, and leave everything else alone. There is another thing you could do, but it's not really all that necessary. Like inside of these parentheses, x squared plus 2x, an x could be taken out. I don't think that's necessary. So what I'm going to have you look at is, do you see in this expression right here, do you see a common factor?
X squared plus 2x to the second.
Exactly, this right here. Okay, so here's the thing that you got to get comfortable with on this, and sometimes students are not used to seeing this as a calculus student, because in algebra you never factored stuff at this level before. I mean, you learned the principles, but you're taking this to a higher level now. Okay, so what do? Which one comes out? The one with the second power or the one with the third power? Yeah, lowest exponent. Good. Okay, so we're going to go ahead and just take that out. X squared plus 2x to the second. Then you're going to draw a big bracket. And see, one of the benefits of highlighting, this even helps students when they do homework and stuff, is I just took that out, so what's left? I would have left, I'd have 2 times 3 is 6. You can go ahead and do that. Okay, 2 times 3 is 6. I have an x plus 2. Okay, then I also have an x plus 1, like that. Now I do have something left here. What's left here? It's the first power, right? Okay, because when you multiply a second power times the first power, it's going to have to give you a third power. Does that look good or bad? It's at a higher level than what you're used to. Okay, that's one of the things you're going to get into when you do derivatives, is being able to do that. Now you can check your answer on this. I mean, if you just sort of multiply that stuff out, you'll have that. So it's in a factored form. The only other thing I would suggest that you do on this is we could FOIL and collect like terms in the bracket, and then we'd be done. And I am going to go ahead and do that on this problem. And we'll kind of see on homework kind of how my math lab, I think a lot of these more complex derivatives are multiple choice, which is good for you. Okay, because then it's not, where do I stop? Okay, that kind of thing. Okay, so let's go ahead and FOIL this. Okay, so I'm going to just put the 6 and FOIL that. So that's x squared plus 1x plus 2x plus 2. Bring this down, and it's to the first power, so you don't need those parentheses anymore. Okay, and then bring this down. Okay, and then multiply this out, so that's going to be 6x squared plus 6x plus 12x plus 12 plus x squared plus 2x. Now all we need to do on that is just collect the like terms, and then we got a good answer, I think. Okay, so again, I FOILed this. That's what I got there, multiplied by 6. So I think everything on that looks good. So let's write as our final answer, x squared plus 2x to the second. Okay, let's see, like terms, it looks like we have 6 plus 1, it looks like we have 7x to the second. For the x's, it looks like 6 and 12 is 18, plus 2 is 20. Okay, and then plus 12. And that looks good. Ah. Okay, that's a beautiful problem. I like this as a future test problem. I do, because it tests a lot of things. The derivatives are not hard, but the algebra, I like students to make sure they can handle the algebra on something like this. So that's it. All right, how's that look? It's fun, right? Derivatives are fun. They are. Okay, and you'll find that. It's okay to say, yeah, this stuff's fun. Okay, I'm going to have you guys go to the next page and do the next two problems. I'll give you a little time to do that. Then I'll go over the last problem. Then we're going to do a short quiz and then do a break. And then the second half of class, we're going to do implicit differentiation and then finish up the 3-6. So go ahead and go to the next page, and you can begin to work on those problems. Does everybody have that copied down? Because I am going to take this off. Are you still copying? Are you okay? All right, very good. Okay. I really like being able to highlight. Does the highlighting help you guys? I would think it would, as from a teacher's standpoint. Because I mean, it's just because you when you deal with messy expressions, it might be helpful for you as a student to even do that sometimes, to kind of keep track of stuff. Okay, so I'm going to take this off because I'm going to let you guys work on this a little bit. And I'm going to go ahead and work them out, and then when you're done, you can kind of compare them with my solutions, okay? try to simplify these as far as you can, too. Just try. Like I said, I think when you're doing your homework, I think My Math Lab does these more multiple choice, so it does help.
You want to do 1 and 2?
What's that?
You want to do 1 and 2?
Yeah, try both of them. Now, if you compared answers on one, I bet there would be a lot of differences. I'm going to see how many of you get down to what I'm after, but, just try your best. You're just beginners, but you'll get it.
Oh. I got it. Oh, so it's a quotient rule. Did you do the quotient rule?
Yeah.
Okay.
I got there. I got it.
So these cancel out, right? These are like terms. Okay. And then, oh wait, actually distributed first. Distributed cancel. No, so that's like.
Let me just kind of talk through a few things. I was kind of hoping that I could get you down all the way to the bottom. Over kind of in this column here is mostly the algebra going on. So did anybody make it all the way to here? I'm just curious. Very good. Not bad. And I think like Ben, you had multiplied out, so which is fine. So that's good. Okay. Now let me talk through a couple of the issues on here. I think the thing that you want to make sure that you did on the derivative is you start with a power rule. So you should have on this one, of course, taken the 3 down, that to the second times derivative of inside part. So you want to kind of just look at your work and see where if you made any mistakes and where you made mistakes. Now, so step 1 is chain rule, really. So you're bringing down the 3 derivative of inside part. Then you should have used the quotient rule, right? So you bring this down, you have 3e to the t minus 1 the second. Now all this stuff right here is the quotient rule. So notice I'm doing bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay? And then I just kind of keep rewriting this stuff right here. So when you simplify out the quotient rule, because really it's the algebra more that you're going to have questions about more than likely. So what I've done is after I did the quotient rule, and of course derivative of e to the t is e to the t, derivative of t minus 1 is 1, so we got that. So let me just ask you guys up to this step, does that look okay to everybody up to that step? Okay. If you got that, you got the calculus under control. Okay, if you made it to that point. Now let's kind of talk through some of the algebra on here. Okay. I went ahead and broke this up. This is a wise thing to do. Just write this as e to the t to the second, and write the bottom as t minus 1 the second. Okay, everything is in parentheses, so then just rewrite it that way. Break it up. E to the t to the second, t minus 1 the second. Okay, then I just kind of wrote this like it was there. Okay, the reason I do that is notice you can put these two things together, right? So t minus 1 to the second times t minus 1 the second is t minus 1 the fourth. That way you can put that together. Does that make sense? Okay. All right. So when I do this now, where did this e to the 2t come from? You're multiplying exponents, right? There's the rule that says if you have a power to a power, you multiply the exponent, so that's 2t. Okay. So I did that. Now I did multiply this out. So I did what? So I did on this, I did e to the t times t, like that. Then I did e to the t times 1, bringing the e to the t down there, and then I collected like terms primarily. These two things right here are like terms, so that's 2e to the t. And then I factored out on that, basically, is what I did. Okay? Well, you can get that written down, and you can kind of think through it, but is there any major questions that you have on the algebra part? Okay, so it sounds like some of you did pretty good there.
I mean, so just right there, is it like, am I still like heading in the right direction? Because that's the furthest that I got.
Yeah, I think your quotient rule is off a little bit though.
Okay.
I think what you need to do is go back. What you need to do is look on your paper and double check your quotient rule, because your quotient rule result is really this, what I just highlighted. And I think you're off a little bit on that, okay? All right, so let's go through this next one here, and I'll go ahead and just move this down just a little bit here, because you want to study over the algebra. The algebra is what you have to work on these problems a lot, but like I've been saying, you'll get a lot stronger with your algebra as a calculus student. You're seeing why by now. Okay, on number 2, did you use the product rule? Okay, you got to start with product rule. Okay, so you're doing the first. I'll just kind of talk through this and you can see how far you got. First times derivative of second plus second times derivative of first. Okay, that's knowledge of product rule. Okay, now when I did these two derivatives right here, those are chain rule derivatives. Okay, so you want to kind of look and see what I did there. This derivative right here, I'm doing that. Bring down the 3, multiply by derivative of the inside part, and then this derivative goes there. Okay, that's chain rule. So you're doing a product rule, then a chain rule. And then from this point, the hardest part of this for most students is the algebra and the factoring. Okay, so now when I cleaned up this derivative, okay, when I do this derivative, that gives that piece right there. When I do this part right here, that gives that part of the problem like that. So really, at this step right here, the calculus is done. So one thing you want to do on that, if you got through that problem, is you want to see if you did that part right. Okay? Now tell me if that part that I put a check mark by, if there's any questions on that. Okay, now it's basically time to clean this stuff up, and that's what I did. And then there's factoring involved. So what you want to do on this is you have 3. I just wrote this whole thing right here. This thing right here, I cleaned it up and wrote it like this. I didn't do much with it. I just brought the 3 in front. And then this part right here, a little simple arithmetic. 2 times 2 is 4. Then I wrote it like that. Okay, now it's factoring time. Right, now what you got to do on factoring is you got to look at what's in common. Well, you have a 2x minus 5. You have 1 to the second and 1 to the first, so you're going to take out the 1 to the first power. Then you had a x plus 1 to the second and an x plus 1 to the third, so I took out the one with the lowest exponent. Like that, okay? What was left after you did that would be this and this. And from that point, you're going to be fine because it's basically distributive property and collecting like terms is what you get from that. Okay? All right. Some of you have a funny look on your face. Like, man, what am I doing? Okay. So you guys think you can handle that algebra? Of course you can. Okay. We want you to make it all the way to the end of those kind of problems when you're doing that then. Okay, I'm going to slide this down just a little bit. You can still copy. I know that, did anybody happen to get to that? I probably didn't give you enough time to get to that point, but you got to it? Almost? Okay, all right. You want to try to factor as far as you can, okay? Well, let's finish this, then we'll do our quiz, then we'll do a break here. Then the second half class, we're going to do implicit differentiation mainly. I just kind of liked this problem. I took this out of the book, and I'll move it up a little bit if you still need to copy. Okay. All right. Now on this one, let's just kind of do these together. You're doing h prime of 3. However, what they do is they give you h of x is equal to a composition of functions f of g of x. This is actually a good problem because it kind of helps to see if students understand the chain rule more in this form. Okay, so when we do the derivative of f of g of x, the chain rule says that you do this. It says that you just do the derivative of that. But then you have to multiply by the derivative of what's inside, which is g prime of x. That's what you've been doing, okay? Now, one of the things I did at the very beginning of this section, that's how I started the section, is I gave you that rule. And I said you probably wouldn't understand the language of that until you did some problems. But that's what we've been doing over and over again is derivative multiplying by the derivative of the other part, what's inside usually. Okay, so what you do on this problem then is they gave you enough information in this table to figure this out. So g of x, what you do is, and we're doing really 3, let's go ahead and write this as f prime of g of 3 times g prime of 3. The rest of the problem becomes an arithmetic problem. Okay, all right, so what we'll do with this then is g of 3, okay? Here's 3, g of 3 is this row, so you're there. Okay, so g of 3 is 1 according to that table, so that's going to just be a 1 like that, okay? G prime of 3 is this row. Here's 3, just kind of match up your column and your row, so that's going to be 20 like that then. Okay, so we end up kind of having that idea on that. So we have f prime of g of x, and we got that okay, and then multiplied by g prime of x like that. So what you're going to end up having is f prime of 1, and we do have to do that also. Okay, so if you look at f prime of 1, okay, we got to do that. Here's 1. What's f prime of 1? 5, okay? So it's 5 times 20, so it's 100, okay, like that. Okay, now, I'm not going to do the second one. You guys don't have to do the second one. I just wanted to do a basic example of that to kind of